Hi, I'm John Brown, a grad student in the astronomy department at Ohio State, and in this coffee brief I'll talk about some results from my recent paper on the ultraviolet spectroscopic evolution of the nearby tidal disruption event IPTF 16FNL. When a star gets close to a supermassive black hole, the tidal forces can be so strong that they actually pull the star apart, and this typically produces a bright flare of emission in the optical, UV, and sometimes even X-rays that can be detected by transient surveys. IPTF 16FNL was discovered by the Intermediate Palomar Transient Factory in August of 2016, and shortly thereafter it was classified as the most nearby TDE ever discovered. We also detected the object in ASSASSIN data and decided to trigger our Hubble Space Telescope Target of Opportunity program, as well as coordinate and follow up with a number of other observatories, including the Swift Space Telescope. The highlight of our paper is the UV spectroscopic evolution of a TDE, which has never before been observed. Our initial HST UV spectrum was taken approximately 2 weeks after discovery and is shown here. The squares show our contemporaneous Swift observations. We subtract the host flux, which is shown as the gray line, and model the excess flux using a blackbody model, shown as this dashed line. The spectra showed a blue continuum rising into the far UV, and strong carbon, nitrogen, and silicon resonance lines typically seen in the highly ionized gas surrounding active galactic nuclei. We also see evidence for broad blue-shifted absorption associated with these features, which could be evidence for some sort of outflow associated with the TDE. Interestingly, there's no evidence for magnesium-2 emission, which is typically observed in active galactic nuclei, but appears to be absent from the spectra of TDEs. Our second spectrum was taken approximately 2 weeks later and shows many of the same features observed in the first spectrum, but by this time the TDE was substantially dimmer and the lines appeared somewhat narrower. Again, this is in contrast with what is typically observed in active galactic nuclei. In our third spectrum, taken nearly 2 months after discovery, we see that the TDE has continued to dim and the highly ionized lines have become even weaker and narrower. Interestingly, the helium-2 line in the UV has remained relatively strong even in the latest spectrum. We also obtained a series of optical spectra at both early and relatively late times in order to monitor the optical evolution of the flare, but also to characterize the nature of the host galaxy. As was the case for many previously discovered TDEs, the host galaxy of IPTF 16FNL is clearly a post-starburst galaxy, which provides further evidence that TDEs are preferentially found in this rare type of galaxy. We also obtained UV and optical photometry with the Swift Space Telescope and ground-based observatories. The object was discovered in the optical bands due to a relatively subtle increase in brightness relative to the host galaxy, which is shown here at early times as the deviation of the points from the horizontal dashed lines. Even the early measurements from space only showed a modest excess above the host flux in the optical bands. However, in the UV filters, the transient was several magnitudes brighter than the host at early times. The brightness decreases fairly rapidly compared to other TDEs, but even after 100 days, there's still a non-negligible amount of excess flux in the bluest UV filters. We compute the luminosity implied by the UV and optical photometry and compare it to that of TDEs discovered by ASSASSIN. While the inferred temperature was comparable to other TDEs, IPTF 16FNL remained much dimmer than other optically discovered TDEs, and its luminosity decayed very rapidly. Finally, we're able to exclude the presence of any X-ray emission with relatively strong upper limits, which are shown here with the downward pointing arrows. Those are the main results of our study, but if you're interested in some of the finer details, make sure you take a look at our paper on the archive. Thanks for watching.